Now we come up with these culminating three ideas. We talk about de Broglie waves, which, here we are talking about double-slit experiments and how matter does have a wave-like property, and that wave is allowed to interfere with itself and creates these bright and dark spots, which was a phenomenon. But it says, oh, look, we may have wave-like properties associated with those electrons. Well, then we have photoelectric. The process is all or nothing. Then an electron down here will either absorb or not absorb. And it'll only absorb once, and it'll be liberated, okay? Or not, okay? So Einstein's photoelectric is all or nothing. And then you have Bohr, who, looking at Einstein's model, has been validated. He says, well, it's an all or nothing process. That it's either here or here, depending on how much energy it is. And that energy is based on this all or nothing process, okay? So we have that phenomenon going on, and we have these three ideas floating around. We already found out that the Bohr model works great for hydrogen, but it doesn't work for anything else. So we've kind of taken an amalgamation of de Broglie's idea about wave nature and the Bohr model, and we come up with a new model. And the new model says, well, we have a wave-like nature, so instead of thinking of it like this, we can think of it like that. That those particles are vibrating in that system, and because of that vibration, that's why the Bohr model failed when we measured every single other atom besides hydrogen. Well, it turns out that they're all wrong. Well, they're not all wrong. This is true. This is sort of true. And this is, well, not true at all, except for hydrogen. So you're talking about Nobel Prizes, and it's all wrong. It's not proving anything. I mean, obviously the photoelectric effect is still proven. It's still true. But it doesn't, we can't use that information, apply it to the Bohr model, which then says all or nothing for these steps, and it doesn't give us an accurate model. It doesn't give us an accurate representation of why we're getting the spectrum of light for other lights, or for other atoms other than hydrogen. Sorry, my brains are going a little fuzzy. So what do? Well, you get another guy. Excuse me for a second. And this other guy is by the name of Schrodinger. Schrodinger does something different. He looks at the results. He takes all the data. He sees the wave patterns. He sees what spectrums of lines are being generated. And he comes up with a mathematical equation to predict that motion. Okay? So he comes in there and he makes a prediction. He says, I've got this model. I think it's right. And then he applies it. And he's proven right. That when dealing with the atom, that you can use Schrodinger's equation to predict those energy levels. The interesting thing about that, unlike applying de Broglie to Bohr and saying we have a wave-like property going on, Schrodinger and his equations offer no insight. If you will, it's like pre-Newton in motion. Okay? So we had kinematics. We had a way of describing motion, but we don't know why. It's not until we start talking about forces and inertia and all that other stuff that we get an understanding why things behave the way they do. Well, Schrodinger comes up with the equation that predicts the motion, the probabilities, the momentum, those functions, but with no insight on why. So we're still at that point where we have the equations that predict the motions, and we have theories about the insight, but we don't necessarily know if those theories are correct. So Schrodinger gives us the tools to understand the atom, to look at and mathematically predict locations. Now, here's something that drives me crazy that I've seen on a lot of textbooks. Mind you, Schrodinger's equation does not determine the point in which a particle exists. It determines the region. It's a probability. So you cannot have the probability of a single point. You have a probability of a region. So that's what Schrodinger's equation is all about. But that's off on a tangent. But so now we're stuck. We're stuck with an equation with no understanding, waiting for Newton to come along and give another Newton, if you will, to come along and to give us an understanding why things behave the way they do. Okay? So that's Schrodinger and what he did for us.